Hello, my name is Moshe. I'm going to present Intel fastRAG, which is a efficient RAG on Intel hardware. And just to present myself, I'm leading the NLP team at Intel Lab. My team is very active in publication, top-tier NLP conferences, also collaboration with academic partners and industrial labs. Uh, give you just an example of what my team is doing from right to left. Our main expertise is AI acceleration algorithms, and starting from extreme optimization. For many tasks, you can run, for example, text classification or name entity recognition. You can deploy very efficient methods, even in 2 or 3 order of magnitude, and run it very efficiently on CPU. I will give an example in a few slides. In addition, we are doing AI acceleration on all Intel hardware platform from Xeon, our CPU, Gaudi, AI accelerator, and our core, which is kind of optimization on the client side. Here we have an example of start order 15 billion up to 7x speed up on a 15 billion model, which is which is great, more than 40 tokens per second. And on the left side, we're also doing fine tuning and pre-training from scratch, building new models. And recently, we had a newer chart which actually outperformed Mistral and was one of the top 7 billion models in Hugging Face leaderboard. So let's start with some extreme optimization example before getting to the fast drag. And I want to remind you that we have our framework SetFit. You have all the link here to get to the GitHub and the code. And this is a joint development with Hugging Face and UKP. And in last year, we had more than 1.5 million downloads, more than 1,500 model actually in Hugging Face Hub. This is a very practical framework if you want to do text classification, few shot, even full shot. And recently, we also add new capabilities like aspect-based sentiment analysis, and we're planning to also add name entity recognition. Just to give some why SetFit is actually very popular, because really, if you see here on the left side, this is from a paper that benchmark banking 77, which is a financial intent detection data set. You can see that with only 5 shots, we're actually comparable to even GPT-4. And I remind you that SetFit is about 100 million parameter models and even below that. So this is quite exciting to run a model on, with 10 million parameters, of course, on any platform. And as I mentioned, also in our recent release, we have contribute aspect-based sentiment analysis. And you can see here an example tracking COVID-19 discourse on Twitters in North America. And what we are interested is to find the positive or negative on specific aspect on those Twitters. So how many sentiment reaction about, for example, specific travel or orders or specific countries. So not just to understand the statistics of the positive or negative sentences, but also understand what are they saying about specific aspect. And you can see here, this is maybe a more example from a customer service. Someone saying the owner is super friendly, so the aspect, of course, is the owner, and the sentiment is positive related to the owner, and also service is fast, so the again positive related to the service. And what we did, again, this is based on SetFit, a 100 million parameter model. And what you can see here, this is a benchmark. On the right side, we see a benchmark on Fika data set compared to Bloomberg GPT, 50 billion model. And you can see that after only using 50 samples, we outperform, SetFit apps outperform a very large model like Bloomberg GPT, and remember that Bloomberg GPT was trained on financial data. SetFit APSA was not trained on financial data, only fine-tuned on 50 samples. So it's really great that we can get much more accurate performance with a model size that is even 5 times smaller. And of course, label 50 samples is not a huge effort. In addition, in our latest release, we also include optimization with a framework called Optimum Intel. And this is an open source library that accelerate end-to-end pipelines that built with Hugging Face library on Intel hardware. So the Intel Optimum include different techniques for optimization, from quantization, pruning, and distillation. And what we see here is basically performance versus sentences per second. How many sentences you can run on inference versus bet size. And you can see that we can even get 7x better than the vanilla, which is called BF16, which is basically what you get from Hugging Face if you are not doing any optimization. So it's really, getting around 1,000 sentences per second on a CPU for classification, name entity recognition. This is great. Okay, so now moving to fastRAG. Yeah, so RAG, retrieval augmented generation, really become an hot topic. And I think it's very important also to run on your client side, specifically if you want to retrieve your documents. And here are a few examples. Of course, for the medical Q&A, this is medical advice. This is quite popular. And also for other domain like customer service, you want to get answer for questions or financial report, getting answer regarding financial report. And the workflow, I just will go over it quickly. You're starting with indexing your documents, then you have a query, and you try to find similar documents. Then you pull out the top documents, and you combine it with your prompts in order to get into the LLM, to your language model, to generate an answer. So this is a basic flow, a vanilla flow of a RAG. And we have today great framework like LangChain, Llama Index, HiStack, that allow you to build RAG pipeline for specific use cases. So why you need a fastRAG, and what is fastRAG? So what fastRAG is basically an open source research framework built by Intel Lab, and it's not competing with those frameworks. It's actually complementary to those frameworks. It's kind of an extension. So in order you to run efficient RAG on Intel hardware, you can extend or integrate building blocks from fastRAG to those popular framework in order to run them efficiently on Intel hardware. Of course, you can also utilize fastRAG, which is fully compatible today to HiStack. So basically, it's like getting the pipeline as HiStack, but you can also extend other frameworks with IP and building blocks directly from fastRAG and benefit from all the optimization that you have on Intel hardware. And I will give a few examples. So here is the kind of overview of the architecture. It's very flexible, agile. So and basically from the query side to the LLM, you can you have very much flexibility and examples to switch models and to get all the state-of-the-art retrievers, generators optimized on Intel hardware. So from left to right, we have, of course, access to all the vector database like Quadrant, Weaviate, Pincon, and in the retrievers we have from BM25 to, of course, sentence embedding, Colbert, Plaid. And on the generation side, we have, of course, all the LLM models that is available from Hugging Face, and methods like Fusion Decoder and Replug that are actually considered to be state of the art if you want to do generation with RAG. Today we have close to 900 stars, and I encourage you to go into our GitHub, fastRAG, Intel, and give us a star, and have a look on the examples. And of course, as I mentioned, the advantage of using fastRAG is that you can get all the optimization on Intel hardware from our Xeon platform, Gaudi, the core, the client side, Intel GPU, and of course to benefit with all our optimization libraries like Intel Neural Compressor, which is one of the Intel optimization framework, also Intel extension for PyTorch that optimize LLMs, and also with the recent availability of framework like Onyx and Llama CPP. Okay, so just to give a kind of a short um, intro about the latest features of fastRAG, we just had release of fastRAG 2.0. It includes many examples of given notebooks. There is a pipeline via REST API that you can activate. We have also demos that you can run with Chainlit. And the new features are, as I mentioned, are basically most of them are optimizations. So we have the Intel Gaudi accelerator. So if you have access and you run Gaudi, you can, in one line of code, you can run your models with Gaudi with full optimization. We have support for Onyx runtime, so running LLM with optimized Onyx with Llama CPP. We optimizing the embedding models and the re-ranking process, and I will give an example in a minute. And of course, RAG efficient components like Colbert, Fusion Decoder, Replug, and Plaid, which are actually available from fastRAG and are optimized for CPU. As I mentioned, we have many examples, and you can go into our GitHub and you can see the list of all the and the link that we have for the notebook. For each example, basically you can follow the example, how to optimize specific model or how to optimize specific use case, if it's a Q&A, summarization, or all the models that I just mentioned. So it's quite easy to navigate and follow the notebook. So let's just to review a few examples from Gaudi, Xeon, and I'm going to demonstrate in the last few slides, I'm going to demonstrate how you can run efficiently the RAG on client side. So start with Gaudi. This is our AI accelerator. You can easily run Gaudi with fastRAG, and this is an example from HiStack. Just adding one line of code. If you have the model, you're adding one line of code, and again, all the examples here are available in fastRAG as part of our notebooks. And so you basically can build your RAG pipelines. Don't worry about the model itself. Eventually, you can run it efficiently on Gaudi 2 if you have access. Related to Xeon, so I want to demonstrate we did optimization for semantic search with RAG. And as you know, as I mentioned, there is three primary usages. One is indexing, when you have the documents, and you want basically to create for each document or for each sentence, you want to create the embedded vector. Usually you need some higher throughput. You want to process more sentences per second. When you are doing the query encoding, you're probably interested in the response time, which means lower latency. And also when you do ranking, you want fast response. So this is exactly what we can give you with fastRAG. And with all the latest and greatest bioencoder models that you can see, that actually you can go to Hugging Face MTEB leaderboard, you can see all the list of the bioencoder models that actually been integrated for RAG system, mostly for ranking and retrieval. And our optimization is basically, and I will show in the next slide, how we optimize those specific usages, specifically ranking and query encoding, how we optimize it to Xeon, to our CPU, and of course, without getting any loss of accuracy, which is very important. We don't want to hurt or degrade the accuracy of the model, of the original model. Remember that you have to go from FP2, 32-bit to int8. Okay, so here are the performance. On the upper left, on the upper right, you see the accuracy for a model that it's called BGE. And you see there is no significant degradation of the performance in terms of accuracy. And what we see here on the graph, the two other graphs is on the left side, we see latency, response time, getting even more than 10x with optimum intel on latency, on response time, and related to throughput, we can even get more than 5x on how many sentences you can process in 1 second. So great improvement with optimum intel for those workloads. And just I want to conclude with running a RAG on client. And what we did is enable RAG on our local client. And we integrated all optimization framework like Onyx, Llama CPP, and our own OpenVINO. And we compare the performance on our Meteor Lake CPU, and we simulated a real RAG workloads. And what I want to share with you now is 3 demos, just to have the experience how you can run RAG workloads on a client side. So the first one is running with Phi2. Phi2 is a surprising powerful model by Microsoft, 2.7 billion model, and quite powerful, at least as comparable to even to Mistral 7 billion. And I want to just demo a chat running on Intel Core. And you can see here, the model was quantized to 4-bit and running on our Meteor Lake on the Intel GPU. And again, this is running on the client side. And you can see, I will try to run. Hopefully you can see the experience. You can notice the experience. How fast is it? And here is a chat. I'm asking a question. Can you please summarize US healthcare reform? And you will see it's running about 100 tokens in 5 seconds. So again, this is the experience of running a chat on your client. If I move to the second example, it's a code generation example, running the same model Phi2 now for a code generation. And again, this is running on the Intel GPU on the Meteor Lake. And you will see the experience of using code generation. The question I'm asking is write a Python code, write a Python function to perform binary search over a sorted list, use Markdown to write code, and you see how fast it's run again. And the last one is, the last example is running RAG. And basically, again, same model with a combination of RAG. Of course, you can choose files and again, ask specific questions about the file. This is just a simple example, but the answer, the response time is quite fast. I'm asking how many SKUs does the Intel Core Ultra U series have, and I get the response again in few milliseconds. Okay, so that was the kind of that was the demo. This is quite exciting. I really think that RAG can shine on client side. This is really important to get AI on PC, and the experience of running the LLMs and RAG capability on the client side is really exciting. And as I mentioned, fastRAG is part of Intel software platform. You can see here, for example, it's the software suite with OpenVINO. And again, if you have more questions, please feel free to ask. Thank you very much.